Hello students of standard 8 subject maths lesson number 3 understanding quadrilaterals. But here we are going to see kinds of quadrilateral. Okay, kinds of quadrilateral. First of all, we'll see trapezium. Okay, in trapezium, one pair of opposite side is parallel, then that type of the quadrilateral, only one pair in trapezium. If in a quadrilateral only one side, one pair of side of opposite side is parallel, then that type of quadrilateral quadrilateral is called trapezium. Okay, only one side is parallel. Example C: A, B, C, D. In quadrilateral, this is a symbol of quadrilateral. A, B, C, D. AD is parallel to BC. AD parallel to BC. AD is parallel to BC. Then this type of quadrilateral is known as trapezium. Here AB and DC are not parallel. It is not given here. Okay, then this type of quadrilateral is trapezium. Okay, now we know that the sum of the measure of all angle of quadrilateral is 360. But in this, here measure angle A plus measure angle B, A and B, looking this figure, and according to this condition, AD is parallel to BC, and then A plus B is equal to 180. There measure angle B plus measure angle C is 180. Why 180? Here they are forming interior angle. First pair of interior angle is A and B. They are interior angle. These two are parallel and this is transversal line. Here these two are parallel and this is transversal line. So they are forming angle A and angle B. Here angle D and angle C are forming pair of interior angle. Is that clear? So this is the property. Here diagonal intersect each other, but it is not said that whether they are bisecting each other or not. It is not said. By diagonals bisect each other. Diagonal intersect each other. Intersect means they are cutting at some point. That means it does not bisect. It is not said clearly. This is the type of a kind of a quadrilateral where only one pair of opposite side is parallel. Then that type of the quadrilateral is known as trapezium. In quadrilateral ABCD, AD is parallel to BC. Only one pair of opposite side is given here parallel. Other pair is not given. Its condition is not given. So this type of the quadrilateral is known as trapezium. Okay, here A and B are forming interior angle. Then sum of these two angle is 180. B and C are forming interior angle. Then this sum of these two angle is also 180. Is that clear? Now next is kite. Next quadrilateral is kite. Here kite. Next type of the quadrilateral is kite. Okay, in kite. Okay, what is the property of kite? Kite is a special kind of a quadrilateral where two adjacent sides are equal, where pair of two adjacent sides are equal. Here, let's see. A, B, C. AB is quadrilateral A, B, C, D. AB is equal to AD. These two are adjacent angle. These and these are their common vertex, that is A. So AB and AD are equal. These two are equal. Another pair is BC equals to DC, and these two pairs are equal. Here, okay, a kite has four sides, four angles. It has two diagonals. It is also kind of a quadrilateral. Okay, it is a quadrilateral. There are exactly two distinct consecutive pair of side equal length. Consecutive means two both adjacent, two close sides adjacent or consecutive pair. Distinct consecutive means close are equal. Then this type of the quadrilateral is known as kite. Okay, is that clear? Now, next type of the quadrilateral is parallelogram. Next type of quadrilateral is parallelogram. Let me explain this. What is parallelogram? In parallelogram, opposite sides are equal and parallel. Okay, opposite angles are equal. Is that clear? By diagonals bisect each other. Okay, and the sum of two adjacent angle or consecutive angle is 180. Sum of two consecutive pair of angle is 180. Okay, here example I am saying x, y, z, w. This is a quadrilateral where xw is parallel to yz and xw is yz is equal to yz. Though xw is parallel to yz and xw is equal to yz. Here second xy is parallel to wz and xy is equal to wz. Opposite angles are equal. Angle x is equal to angle z angle W is equal to angle Y. Measure angle X plus W is 180, W plus Z is 180, Z plus Y is 180, Y plus X is 180. Then this type of the quadrilateral is known as parallelogram. Your diagonal XZ and WY intersect each other at M. Here XM is equal to MZ. If XM is 5, MZ is also 5, YM is 10, then MW is also 10. Here diagonals bisect each other. Diagonals bisect each other means if this is 10, then it will be 5, 5. If it is 20, then it will be 10, 10. Like this, it is said. This type of the parallelogram is known as, this type of the quadrilateral is known as parallelogram. Next, type of parallelogram. Okay, type of parallelogram. There are different types of the parallelogram are there. Square, rectangle, rhombus. These are the three types of the parallelograms. Let us see their property. There are three types of parallelogram. They are: first, square, rectangle, and rhombus. Square is also known as parallelogram, rectangle is also known as parallelogram, rhombus is also known as parallelogram. Why they are called square, why they are called rectangle, and why they are called rhombus? Let us see. In square, all sides are equal. Okay? All angles are right angle, 90 degree. Both diagonals are equal and bisect each other at 90 degree. That means both the diagonals are perpendicular to each other. Look here. Example is square tiles. A, B, C, D. AB equal to BC equal to CD. All sides are equal. This angle is 90. This angle is 90. This angle is 90. This angle is 90. AC, here both diagonals are also equal here. Both diagonals are equal and bisect each other at C. These are the diagonals. AC equal to BD and they are intersecting at 90 degree like this. Is that clear? This is a kind of a square. Now rectangle. Let us see rectangle. Rectangle is also parallelogram if opposite pair of sides are equal and all angles are right angle, both diagonals are equal but they do not intersect at 90 degree, then that type of the parallelogram is known as rectangle. Here opposite pair of sides are equal and parallel. Okay, all angles are right angles, both diagonals are equal, but it is not compulsory that they intersect at 90 degree or they are perpendicular. Here, example of rectangle is this blackboard. What is the difference between rectangle and square? In square all sides are equal, in rectangle only opposite sides are equal and parallel, but this and this side to adjacent may not be equal. Okay? Here. P, Q, R, S. PQ is equal to R, S or SR. PS is parallel to QR. PQ is equal to SR. PS is equal to QR. Angle P equal to angle Q equal to angle R equal to angle S is equal to 90 degree. Your diagonals PR equal to QS, but they may intersect at 90 degree or may not intersect. If they intersect at 90 degree, then that rectangle, that is also rectangle, and that rectangle is known as square. Okay? Now, one note. Note, all squares are rectangle, but all rectangle are not square. P, Q, R, S, X, Y, Z, W. But I said all squares are rectangle because all the property of square are also in rectangle. But all property of rectangle is not in square. What is the property of square? See, opposite, all angles are 90-90. Here also all angles are 90-90. Both diagonals are equal. Both diagonals are equal. Opposite pair are parallel. Opposite pair are parallel. So this square can be rectangle, but this rectangle cannot be square. Why? Because two adjacent sides are not equal. This is the only difference between these property. Is that clear? Now last one is rhombus. What is it? Rhombus. Let me explain the property of rhombus also. See, what is rhombus? Rhombus. In rhombus, if all sides of a quadrilateral are equal and parallel, then that quadrilateral is called rhombus. So look here, in rhombus and square, all properties of square are also in rhombus, and all property of rhombus are in square. But only one property of square is not in rhombus, that the angle are 90 degree. Diagonal bisect each other. Both diagonal in square are equal, but in rhombus, both diagonal may not be equal. Is that clear? Your angle is not set. Measure of angle is not set. Only this is the property. no property of angle is given in rhombus. So that is why this rhombus is not a square, but all square are rhombus. Note. Here example of rhombus. See. All sides are equal. Suppose 4, 4, 4. A, B, C, D. Opposite angles are equal. These diagonals, both diagonals intersect and bisect each other at 90 degree. But opposite angles are not 90. All angles are not 90. Here in rhombus, both diagonals may not be equal. Is that clear? Now note. All square are rhombus, but all square are not rhombus. Okay, student, if you follow this property, then we can easily do all sums easily. Okay, if you have not followed, you can call us. I'll explain you. Okay, and next exercise we'll do in next week.